Taking a look at the mind-blowing 120 meters tall Starship may make us go crazy. Not just its view, but it is the largest and most powerful rocket on the planet. And it has a heavy roar that cannot be compared with any craft that have ever flew through space. With all 33 engines ignited, this beast will produce a minimum of 3,053 metric tons of thrust or even more. SpaceX had to use clamp clips to hold the Booster 7 on the launch pad while testing the working condition of the 33 Raptor 2 engines installed. But what is shocking is that they were confusing about the clamp. It would be able to hold the vehicle down during a 33-inch and static fire attempt. When they did a 14-engine static fire test for a long time, the booster was filled with less than 10% of the liquid oxygen. It was not even up to half of the tank. We can say with a fair amount of certainty that if SpaceX fills the liquid oxygen tanks to about half full and then does a 33-engine static fire test, there will be less upward force on those clamps, and as such, the clamps won't have much power to fight with. But on the other hand, when both the Starship and the Super Heavy booster are fully fueled, they weigh more than 5,000 tons. That's a lot of weight for the orbital launch pad to hold. How does SpaceX know that the 20 gripped clamps will even be able to hold this much weight? Well, the truth is that in a way, they don't. Let's talk more on how these clamps work and how SpaceX believes it is the hope for the Starship to undergo successfully static fire test. This static fire test was required to ensure that all 33 Raptor 2 engines could fire up at the same time and discharge blazing flames from their nozzles without causing an explosion. And it went off without a hitch. Also, it was the most dangerous and difficult test that SpaceX has ever done at a Starbase factory. Have you ever seen SpaceX fill the booster in Starship while they are stacked on the orbital launch pad? The total mass of the full stack at this time is actually less than what the booster weighs when both tanks are completely full. So this cryo test of Booster 7 has the highest level of thrust the orbital launch mount has ever had to bear. In theory, SpaceX should be able to assume with great assurance that the structure will hold up as designed. The Starship orbital launch mount was built with 3D modeling software, which allows them to simulate the mass of a whole stack and then perform a static structural study on the 20 load arms. While everything appears to be in order on paper, testing this for the first time with a fully loaded rocket and Starship on the pad is definitely not a good idea. Even if they take the safe route and use liquid nitrogen inside the methane tanks, if any of the 20 load arms on the launch mount breaks off and collapse, causing the vehicle to tip over, the results would be hell depending on the direction it fell. It will likely be damaging both the tower and the launch mount, or, in the worst case, crashing with other gas tanks in the factory to cause an instant exit of gas. And who knows if the scenario will result in a terrible explosion in the factory. So, how will SpaceX ensure that these 20 load arms are capable for the task? And how will they avoid this and make sure that all the Starship fires up safely even when fully filled with liquid methane? Let's take a look at the evidence trail that may help us give a closer guess. There is a big crane called Grover in Starbase, and he is a big guy that does most of the liftings outside Starbase since it's mobile. Grover is undoubtedly the busiest mobile crane on Starbase, and it is also one of the longest-serving cranes. It is a one-of-a-kind crane that can convert into various different configurations depending on the job at hand. On the other hand, Grover's configuration used for heavier loads that require the use of his gigantic counterweight tray when even more lateral stability and lift capacity is required, the arms can fold out to either side like a pair of wings, which is probably why it's referred to as the Mega Wing Lift System. If you ever visit Starbase and see Grover in this configuration, just know that he means business, and it's probably something important. Grover is the bigger guy that is responsible of holding the Starship on the launch mount and do several fitting before the booster engines are fired. So Grover will have to assist the mounts in case the fully stacked Starship tries to slip off the launch mount. Now, coming back to the clamps in use, SpaceX tested the clamps load capability by repeatedly raising and lowering the counterweight off the ground. The load tester was moved to the next pair of clamps, and the lead bearing capability of both clamps was evaluated during the next 21 hours. If the test data is satisfactory and SpaceX is sure that the clamps can sustain a fully fueled Starship rocket, the next stages will be a full-stack wet dress rehearsal. After several weeks of suborbital Launch Pad B undergoing multiple modifications and passing a static fire test, a crane hoisted Starship 24 and placed it on a transit stand on Thursday afternoon. However, it appears that SpaceX is not yet ready to lift Starships with the new jig brought to Starbase. Concerning the new Starship lifting jig, which will render the nose cone lifting points obsolete, there are currently no indications that Ship 24 will be returned to the construction site, so it is possible that Ship 24 may be mounted on top of Booster 7 for a complete stack wet dress rehearsal. Within 30 minutes of the booster arriving on the launch mount, the launch tower arms were lifted and lowered twice. This could be a practice run for the impending full-stack attempt. Work on the future Starship and Super Heavy prototypes is now underway at the build site. This pattern in the forms is much more likely to make a shape with a dome than to make segments that can be changed. This is a pretty common way to pour and finish flat concrete work that needs to follow curves. If they were only doing it to stop cracks, they would just pour it all at once and cut it with a saw. If you wanted to cut down on the size of your pour, it would be more simply segmented. These forms are way too complicated to not be for a very specific purpose. Also, it's not to make it easier to replace segment, because if you look closely, you can see that the steel reinforcing goes all the way through. SpaceX has never fully loaded a Starship rocket because they have never put a fully loaded vehicle on the clamp to see if it can hold it. The new load tester was put on the launch mount to simulate the weight of a fully loaded Starship. This way, SpaceX can test whether the clamps can hold a fully fueled vehicle securely. The load test machine is made so that it can hold on to two opposite clamps at the same time. So, these clamps have never been put through the amount of stress that they will have to handle in the end. SpaceX's first Starship orbital launch mount seems to have passed busy stages of stress tests, allowing the company to ship a finished Super Heavy booster to the pad. With the same launch confirmation, the Starship booster is expected to try to finish some of the most dangerous and difficult tests SpaceX has ever done at its Starbase rocket development facilities. The schedule for these tests is not clear, but Super Heavy Booster 7 could soon try a full static fire test of all 33 of its Raptor 2 engines. This would come after several long periods of qualifying tests. Before or after that important test, SpaceX plans to put Ship 24 on top of Super Heavy B7 for Starship's first wet dress rehearsal with the whole stack. If these tests turn out the way SpaceX wants them to, Elon Musk, the CEO of SpaceX, says Starship could try its first launch into orbit as early as late February or March 2023. Do you think SpaceX can lift off the fully stacked Starship by March this year? Let's consider that the SpaceX Booster 7 has just completed a record of its longest static fire test duration that would help to achieve the goal. If you want to know more, just click on the video.